Welcome to Math Challenge 487. Math Challenge for school exams, competitive exams, and junior and senior Olympiads. In Math Challenge 487, we have a circle with center O. O is the center of the circle. And we have two line segments, QB and PQ. And they are at right angles. So PQB is a right angle triangle. The hypotenuse PB is equal to 20 units and the area of this right angle triangle is 96 square units. And we have to find the radius OB. We have to find the radius OB, the length of a radius OB, this right angle triangle, area 96 and the hypotenuse is 20 units. Math Challenge 487. Let PQ be equal to Y. This PQ, let it be equal to Y. And QB, let this QB be equal to X. Now it is clear that QB is longer than radius. O is the center. So QB is longer than radius and PQ is smaller than radius. Because if you join O and P, that would be radius. So PQ is smaller than the radius and QB is longer than the radius. That means QB is greater than PQ. That means X is greater than Y. So when we solve, we will get two values. The bigger value will be the value for X and the smaller value will be the value for Y. Because X is greater than Y, X, that is QB, is greater than the length of the radius and PQ, which is QB, which is X, is greater than the length of the radius and PQ, which is Y, is less than the length of the radius. So X greater than Y. This is important. Now area of triangle PQB is 96 given. So how do you find the area of the triangle? Half into QB into PQ, half into base into altitude, that is half into X into Y. So half into X into Y is 96. So XY will be 192 and 2XY will be 384. Multiply by 4, half XY equal to 96. So if you multiply by 4, half XY into 4, that is 2XY, will be equal to 96 into 4, that is 384. So half XY equal to 96. So XY equal to 192 and 2XY equal to 384. So we got 2XY equal to 384. Now in the right angle triangle PQB, using Pythagoras theorem, PQ square plus QB square equal to PB square. That is X square plus Y square is 20 square. QB is X, PQ is Y and PB is 20 given. So X square plus Y square equal to 20 square and here 2XY equal to 384. So we got 2XY equal to 384 and X square plus Y square equal to 20 square, that is 400. X square plus Y square equal to 400, 2XY equal to 384. So X plus Y whole square, X square plus Y square plus 2XY. So X plus Y whole square, X square plus Y square 400 plus 2XY plus 384, that is 784. So taking the square root, X plus Y equal to 28. Again, X minus Y whole square, that is X square plus Y square minus 2XY, X square plus Y square 400 minus 2XY 384. So 400 minus 384 16. So X minus Y is 4. So X plus Y is 28. X minus Y is 4. From X square plus Y square equal to 400 and 2XY equal to 384. x square plus y square plus 2xy, that is x plus y whole square, and x square plus y square minus 2xy, that is x minus y whole square. So we get x plus y whole square 784, that is x plus y 28, x minus y whole square 16, so x minus y 4. So we got x plus y 28, x minus y 4. So x will be 28 plus 4 whole by 2, that is 16, and y will be 28 minus 4 whole by 2, that is 12. So x is 16 and y is 12. This is the reason why we said x is greater than y, because the values were for x plus y and xy. So the value can be interchanged. The value was for x plus y and x into y. So actually these values are interchangeable, but x is greater than y. That is why the bigger value should be x and the smaller value should be y. That's why it was important to know that x is greater than y. So x is 16 and y is 12. So after getting x equal to 12, y equal to 12, x equal to 16 and y equal to 12. Now extend this line PQ to M. See the dotted line. See the dotted line? PQ is extended to M and BO, or rather BQ, is extended to A. So AB becomes the diameter, that is equal to 2R. R is the radius. So AB diameter equal to 2R, and because this line passing through center will bisect this vertical chord PM, so PQ is 12, so QM will also be 12. So QM will be equal to PQ, each will be equal to Y or 12, because a line passing through the center will bisect the chord. So Q is the midpoint, so PQ is 12, QM is 12, and AB, that is the diameter, is equal to twice radius at 2R. So AB, the diameter, is equal to 2R. QM and PQ each will be equal to 12. QB equal to 16 given, and AB equal to 2R diameter. So the part AQ will be 2R minus 16. The total is 2R, that is diameter, QB 16 given. So the remaining part AQ will be AB minus AQ, that is total diameter 2R minus this QB, that is minus 16. So AQ will be 2R minus 16. So AQ is 2R minus 16, Q to be 16, PQ is 12, and QM is 12. So we got the values of the segments of the intersecting chord, and now we can apply property. The product of the segments of the intersecting chord shall be equal. So AQ into QB, AQ into QB equal to PQ into QM. That is 2R minus 16 into 16 equal to 12 into 12. So 2R minus 16 will be equal to 12 into 12, 144 divided by 16, 9. 2R minus 16 is 9. So 2R will be 25. So R will be half of that. 2R means the diameter. So R will be half of that. That is 12.5 units. We are applying the theorem of intersecting chords. When two chords intersect, AQ into QB should be equal to PQ into QM. AQ 2R minus 16 into QB 16 is equal to PQ 12 into QM 12. So 2R minus 16 into 16 is 12 into 12, and divide by 16 both sides. So 2R minus 16 will be 144 divided by 69. Take the 16 to that side, 2R equal to 25. Divide by 2, R equal to 12.5 units. That is the radius of the circle.
Was that interesting? If you have any other method, we would love to learn from you. We shall come back with more interesting videos. Like, share the videos, and subscribe to our channel if you are a math lover. Till then, goodbye.